All right, friends, it's good to be back here again, and I would like to proceed from where we to continue from where we stopped, and we are still on the topic sum and product of roots of a quadratic equation. And as you can see on your screen, we have been given a particular equation, which is 3x squared minus 4x minus 1 equal to 0. And we have been given that if alpha and beta are the roots of that equation, our main duty is to find those things that we have in the Roman figures. Roman figure 1, Roman figure 2, Roman figure 3, and Roman figure 4. So don't let us waste time with that. Let's just move on. Okay, the first one, I believe we are familiar with that. We have to take the sum of the roots. But permit me to write the quadratic equation first. We have 3x squared minus 4x minus 1 equal to 0. And I know that I will be in need of A, B, and C. So let me list them out. Where A is 3, B is minus 4, C is equal to minus 1. So, and actually alpha plus beta, according to that formula, is minus B over A. So in that case, I'll write the minus that I have in the formula, minus, then B is minus 4. It has its own personal minus, so I'll have bracket minus negative 4 close bracket over A. Our A is 3, and in that case, you see, this is, if you have negative times negative, you have positive 4 over 3. So that is the answer to the first one. The second one says if you take the product, that is Roman figure 2 is telling us to take the product of the roots. So alpha beta, according to the formula, is C over A. So according to what we have, C is negative 1, okay, over 3, and that's all. That's the first and the second answered. Let's take the third one. The third one is somehow interesting, and now what we do now, the other two have their roots, have their base in the first and the second ones. What do I mean by that? Now what I'm going to do now is that I am going to fashion the third question, which is x squared plus, which is alpha r squared plus beta squared. I'm going to fashion it in such a way that it will contain alpha plus beta and alpha multiplied by beta. So I have x squared, I keep calling this x, sorry about that, but alpha squared, alpha squared plus beta squared. Now how do I write this in such a way that it will reflect both the sum and the product? That is all we are about to do, and I would like us to move away from here a little and find out how we can do this. Then I will come back to write out the answer there. So let me come to this region and do something on that. Let's just work on it. Now remember that we have something like this, and in our algebra we are familiar with something like this: alpha plus beta all into bracket then squared. Now this simply means that you can multiply, it means that you should multiply, or you can multiply alpha plus beta, the content in the bracket should be repeated twice. Alpha plus beta, that is the meaning of the squared. It means you should write it twice. Assuming you have 3 as a power, it means you have to write it 3 times. So in that case, we have then alpha plus beta all squared will be equal to, now let me multiply and see what we are going to achieve. Now if I have this to multiply alpha and alpha, we have alpha squared. And if I have alpha again to multiply beta, I will have a plus alpha beta. Then if I put beta to multiply alpha, I will have plus alpha beta. Then if I use this to multiply this, I will have plus beta squared. Now all I need is to make this alpha square and beta square to be on one side of the equation, and I'll pack every other ones here to the other side. That is, I'll have alpha plus beta squared equals alpha squared plus 2 alpha beta plus beta squared. Why do I write that? I have alpha beta twice, so that is 2 alpha beta. So now in this case, now I will move away, I'll move alpha 2 alpha beta, I will move it away from here, I'll move it to the other side. Then we will be left with alpha squared plus beta squared on this side. So in that case, we have alpha plus beta squared minus 2 alpha beta. Then we are left with what? Alpha squared plus beta squared. So therefore we can see that alpha squared, okay, plus beta squared is equal to this. Alright, so therefore I will come back to this place and I'll write alpha squared plus beta squared equals alpha plus beta all squared minus 2 alpha beta. Is that okay? So if you look at the content that we have inside this bracket here, it is actually the sum of the roots. And if you look at the one that you have out here, alpha beta here, it is the product of the roots. So which means that we have been able to express this one here, alpha squared plus beta squared, in terms of the sum and also the product of the root. So that is what we are going to work with. So in that case, I will do it with this one. Okay, we have let's proceed. Therefore, don't forget I got something for alpha and beta the other time. Okay, alpha beta, what is the sum? What answer did we get the other time? So we have the sum, like I said, and we have the product. So let's go back and check what answer did we get for alpha plus beta the other time. Okay, if I check back, I got alpha plus beta gave me 4/3. So I will come back to that place. In this bracket I have alpha plus beta, and previously I have gotten alpha plus beta to be 4/3. So all I will write now in place of this is 4/3 squared minus 2. What did I get for alpha beta in the previous question? That is, I obtained, let's check it together, -1/3. -1/3. So we move here. In place of alpha beta, I'll put -1/3. So we have -1/3, and we finish this up. We have 4 squared divided by 3 squared. I have given the 2 to both of them, the power to both of them separately. Then I have this 2 is multiplying -1, so we end up having -2 times -1/3. We have positive 2/3. And so if we move on, we have this to be equal to this other side is 16/9 plus 2/3. I hope you understand how I got that. And so in this case now we need to take the LCM of the two fractions. The LCM here is 9. 9 in 9 will be 1. 1 times 16, we have 16. Plus 3 in 9 will be 3. 3 times 2, we have 6. By the time we add this together, we'll be talking about 22. Yes, 22/9. So this will be our outcome for the third question. So I would like us to take the fourth one, which is 1/alpha plus 1/beta. So the fourth one, I think I should manage this space. Let's do it here. Let's do it here. Okay. Let's go to Mamigo 4. Mamigo 4. That is 1/alpha plus 1/beta. All we need to do here is to take the LCM. And when we take the LCM, you see the reflection of the first and the second in this one again. So you have this as fractions. You take the LCM. The LCM is going to be alpha beta. How did I know that? Let's recall our secondary school where we have 1/3 to be added to 1/2. Then in that case, the easiest way for us to get the LCM in this case, especially when these two are prime numbers, we just multiply, okay, the two of them, and we have 6. Right? In another way, in other words, what I'm saying is it is 3 multiplied by 2 that we are using in this case, and this will give us 6. How did we get that 6? Is through the multiplication of these denominators that we have here. So the same thing applies to this as well. So I'm going to do that for this one as well. So all right, so let's proceed. Now we have that alpha will go in alpha beta. What do I mean by that? If I have alpha beta to be divided by this alpha, all I'll be left with is beta. So beta times 1, our answer is beta. Plus, let's go again. Alpha beta to be divided by beta again, In this case, when beta divides beta, we are going to have alpha left. Alpha times 1, we have alpha. So at the end of the day, what do we have left? We have at the top, that is the numerator. At the numerator here, we have the sum of the roots. I can rearrange this as alpha plus beta over alpha beta. The one at the top stands for the sum of the roots. The one at the denominator is actually the product of the roots. So what does this tell me? I have already obtained the answer to this in Roman figure 1, and I already have the answer to this in Roman figure 2. The next thing for me to do is just to slot in the values and move on. So what is alpha plus beta? Earlier we got what? 4 over 3 divided by what did we get there? It is a minus 1 over 3 for alpha beta. Now this can be better stated, or can be better written like this, so that it will make our calculation much easier. So let's go. I can rewrite this expression here as 4 divided by 3. Now this division line that I have here, the long division line that I have here, can be replaced with this common division sign that we know. So we have divided by minus 1 over 3. And don't forget, we are back to primary school now. We have to change this one to multiplication. We turn this, take the reciprocal like that and twist this around. We have negative 3 over 1. Therefore, we have, if you look at it very well, 3 will go into 3 once, 3 will go into 3 once, and you have 4 times minus 1, this is minus 1, then 4 times minus 1, okay, times minus 1 is equal to what? Minus 4. So this is our answer. Of course, 4 over 1 is 4, minus 4 over 1 is minus 4. So that's how we have our outcome to be minus 4. We've actually come to the end of this aspect. I left you with this. You can play around with this, and let me know if you have any challenge. Thank you for always being there. God bless you. I'll see you in the next video.